For part 2 here, we're going to once again follow the agenda here. Many of you have heard that you've got to be very, very cautious at interpreting correlations as causality. We never use the word causality with correlations, and I want to give you a couple of examples that show you why that's not the case. Let's say we do the first situation here. Let's say that I do a study and I find that the more children watch violent TV, that later on in life, the more violent crime we find that they commit. So I do a correlation and I find that the more number of hours you spend watching violent TV, the more violent crime you commit. Now, if I run a correlation on that, and I would find what a strong positive correlation, and probably significant, I'd like to assert that watching violent TV causes violent crime. That's what I'd like to assert. But you would have to be very careful with that, because they've actually done research on this, and one of the problems we typically have is people who are actually violent criminals, actually they are violent criminals to begin with, and they simply enjoy watching more violent TV. So, do you know if it's watching TV that is causing the violent behavior, or is it that these people are violent to begin with and they simply enjoy watching violent TV? That problem is called a directionality problem. We don't know if A causes B, watching TV causes violent crime, or if B causes A. So when you do correlations, you have to be very, very careful. You are not manipulating variables. With the BMI and the snoring episodes, I was not manipulating anything. And because you don't manipulate anything, it's very difficult to say that one variable causes another. So one problem with making causal statements is what we call the directionality problem. A second problem has to do with a chart in your book. I think it's on page 522 or something like that. Let's see, 522. They've actually done studies, and they've looked at the number of churches in a given area on the x-axis, on figure 1516, and the number of serious crimes. And if you look at the data on page 522, it looks like the more churches you have in a given area, the more violent crimes, serious crimes, are committed. So would you want to assert that the more churches you have in a given area, the more crime you have? No, you'd need to be very careful about assuming or making a causality link. The problem is what we call the third variable problem, and I think that problem is illustrated, you can see the answer to it on 532. As it turns out, you tend to have more violent crime in larger cities. So the problem is, and in larger cities, you actually have more churches. So yes, where there are more churches, there is more violent crime, but there's a third variable problem, that there are more churches in areas that are larger cities. And it's the size of the city that's causing the violent crime, not the churches. So you have to watch out for third variables. Once again, because you're not manipulating the variables, you can't make causal conclusions. And finally, last but not least, is one more problem, and I can give you the example. If you look at the data here, you can see that we're looking at the example of temperature and number of riots. This is from the 60s. They took temperature on given days and they looked at the number of riots. And if you follow the data, you can see that when temperature was 60, you might have X number of riots in the South. When temperature was 70, the number went up. When temperature was 80, the number went up again. And even 90 it went up. But when the temperature was 100, the number of riots went down. This would be an example of a nonlinear relationship. When it gets too hot, people don't want to go out and have protests. So this is a nonlinear relationship, and you can't really run these correlations when you have a nonlinear relationship. So there are three reasons for being cautious for interpreting correlations as causation. One is the directionality problem, the second one is the third variable problem, and the third one is the nonlinear relationship. And finally, last but not least, let me just go over a few book examples with correlations as well. It looks like we start on page 311 here. The book follows what I'm saying here. If you actually look at, actually in figure 15.1, the relationship between time you need to complete an exam and your exam grade, you can see that's a negative correlation. The longer you take to complete an exam, the worse you tend to do. So that would be a negative correlation with time and grade, probably significant. The second example, and that's on 510, on 511, they show family income and GPA, and you can see there that's a positive correlation. So as one goes up, so does the other. And then on 512, they give an example of beer sales and temperature. As temperature increases, so does beer sales. And then even on figure 513b, coffee sales and temperatures. As temperature goes up, coffee sales go down. So hopefully that makes sense to you and you understand the nature of correlations. Correlations look at the relationship between two variables. We'll cover a little more of this next week in class. Thank you. Bye.